In this video, we'll see an example of the chi-squared test. So let's say we have a box that has 6 different colored tickets in it. We do not know how many tickets are in the box, except it's a very large number, and we do not know how many of each colored ticket there is in the box. So let's say someone makes a guess. This will be the null hypothesis. They guessed that 20% of the tickets are blue, 20% are green, 20% are red, 10% are yellow, 15% are orange, and 15% are purple. And we want to know if this guess is reasonable. In order to answer, we will need to take draws from the box. Let's say we take 200 draws from the box. The number of tickets in the box is so large that it does not matter if we draw with or without replacement. And the number of each colored ticket was recorded below. So 49 of the last 200 draws were blue, 39 were green, 32 were red, 35 were orange, 27 were yellow, and 18 were purple. In order to use the chi-squared test, we do need to have an expected frequency. Now this comes from the null hypothesis. So we would expect that 20% of the 200 draws will be blue. Well, 20% of 200 is 40. Same for green and red. So expected values for each of these is 40. Yellow is 10, so the number of draws we expect to be yellow would be 20, 30 for orange, and 30 for purple. So now that we have the observed frequency and the expected value, we can use the chi-squared test. So chi-squared is equal to, we'll start with the blue, take the observed frequency minus the expected, square it, and divide by the expected frequency. So we have 49 minus 40 squared divided by 40 plus. Do the same thing for green. 39 minus 40 squared divided by the expected value of 40. For red, that's 32 minus 40 squared divided by 40. Then orange, I'll do that on the next line. That's 35 minus 20 squared divided by 20. Yellow I'll do in black so that we can read this. It's 27 minus 30 squared divided by 30. And then purple is 18 minus 30 squared divided by 30. So let's calculate what this is. So 49 minus 40 is 9 squared is 81 divided by 40 plus 39 minus 40 is minus 1, squared is 1, so we have 1 divided by 40 plus 32 minus 40 is negative 8. 8 squared is 64, so we have 64 divided by 40. Plus 35 minus 20 is 5 squared is 25 divided by 20. Plus 27 minus 30 is minus 3. Squared is 9 divided by 30. Plus 18 minus 30 is negative 12. That's 144 divided by 30. Now I'm going to try to make this a little easier to calculate. These all have the same denominator, so I can add them together. We get 82 plus 64. It's 146. So we have 146 divided by 40 plus 25 divided by 20 plus, now we can add these because they have the same denominator. 144 plus 9 is 153 divided by 30. So we're going to take the 146 and divide by 40 to get 3.65 plus 25 divided by 20 is 1.25 plus 153 divided by 30 is 5.1. Now I add across. We have 3.65 plus 1.25 plus 5.1 is 10. So this tells us that chi-squared is equal to 10. Now we have to go to the chi-squared table. Well, actually, before we do that, we need to figure out the degrees of freedom. So the degrees of freedom are the number of categories minus 1. There were 6 different colored tickets, so the number of categories is 6. So the degrees of freedom are 5. You need to know that to read the table. Alright, so degrees of freedom, it's right here, the top left. You go down to 5. Go across the row, we want to find a value closest to 10. 0.55 is too small, 1.1 is too small, 1.6, 2.6, 4.3, 6.6, 9.24, and 11.07. So it's between 9.24 and 11.07. And then you want to go to the top of the column. So the 9.24 is under the 0.10, that represents 10%. 11.07 is under 0.05, which represents 5%. So what we can say is that the p-value, the observed significance level, is between 5% and 10%. Now it's greater than 5%, which means we do not have strong evidence against the null hypothesis. That means whatever that person guessed in the beginning, way up here, may in fact be true. We don't have evidence against it. If you have any questions, let me know.